Hello and welcome to the third in this series of Certified Wireless Analysis Professional Certification Tutorials. I'm your host, Steve Evans, CWNE number 177. This module is entitled 802.11 Packet Analysis. Well, here's what we'll cover in this module. We'll start off with some terminology, and we'll follow up with a section called What's in a Frame. And then we'll move on to 802.11 Security Frames. And then we'll summarize to go over what we've covered in this module. And finally, we'll wrap it up with an exercise to test your knowledge based on what you've learned in this module. So let's start with some terminology. 802.11 has three main types of frames. They are the management frame, the control frame, and the data frame. So let's first talk about the management frame. Management frame's purpose is to assist stations to connect to the wireless network using authentication and association methods. Now in the screenshot there's an example of a management frame of authentication, which is subtype hex 11. Other examples of management frames include beacons, probe requests, probe responses, the authentication as we see in the image, and deauthentication. Now this is not an exhaustive list. Now let's talk about control frames. Since 802.11 is contention based, where all the wireless stations are contending for time to send and receive data, control frames prevent as many collisions as possible, and they do this by reserving the wireless medium through various mechanisms. Now some of these examples of control frames include request to send, or RTS. This image is of an RTS frame. Now there's also clear to send, or CTS. There's acknowledgement frames, or ACK. There's PS poll. And there's also block ACK request. And this is also not an exhaustive list. Data frames, as the name implies, carries the data payload between wireless devices. Now some of the examples of data frames, if you examine it from a packet level, include QoS data as pictured here. There's also null function frame. There's also a simple data frame. This is also not an exhaustive list. Now let's talk about what's in a frame. We start off by revisiting passive scanning of a wireless station versus active scanning. With passive scanning, beacons are pushed from the access point that contains the network ID or the network name of the wireless network. Now all wireless stations within range can see the network ID of the wireless network but do not associate. Now on the flip side, active scanning sends out probe requests for a specific SSID, or service set identifier, that's configured in its wireless profile. Now as you may recall, a beacon frame, which is a management frame of 802.11 subtype hex 8, have a specific cadence between beacon transmissions, and that delta is dictated by the target beacon transmission time, or TBTT, and that equals 1024 microseconds, or 102 milliseconds. Let's take another look at 802.11 wireless station association states from a packet level. Now in this Wireshark graphic, you see that a station sends out a probe request and receives a probe response from the access point. That station sends out an authentication packet, which is acknowledged and accepted. Now this is followed by an association request. The access point responds with an association response. Now if the association response was accepted, then a four-way handshake between wireless station and access point takes place. Well, this is another Wireshark view using a flow graph that illustrates the communication between wireless station and access point during the association, from probe request all the way down to the four-way handshake. So if you viewed some of the other modules, you may be familiar with this graphic. It represents the EAP process overview for an enterprise level security. Now the wireless station is the supplicant. The access point represents the authenticator, And the authentication server contains a database of valid users that are allowed on the network. Then the process starts by the supplicant or wireless station sending out an association frame to the authenticator. And this is followed by n=start. And at this point, access is not granted for the wireless station. The authenticator responds by requesting the wireless station credentials for identity. And the wireless station or supplicant responds by supplying its identity or username. The authenticator forwards the access request onto the authentication server along with the identity of the supplicant. And in response to the access request message, the Radius authentication server sends an access challenge to the authenticator, which is forwards to the supplicant. The supplicant responds with a challenge response that's forwarded to the authentication server via the authenticator. Now, if the response to the challenge was valid, an access accept message is sent to the authenticator, which is forwarded on to the supplicant. At this point, the four-way handshake can take place, and the supplicant is allowed onto the network. Now let's dig deep into the actual EAP-PEAP process from the packet level. This is an example of a PEAP authentication. The process is divided into two phases. This example starts off in phase 1, where the authenticator requests the identity of the wireless station. Wireless station or supplicant responds with the identity in the form of a username. Now, phase 1 is sometimes referred to as the outer identity. At this point, the authentication server sends a start flag, and in this case we are using PEAP. The supplicant starts the session by sending a client hello message to the authentication server, and it also sends all the cipher suites that it supports. The authentication server replies with a server hello with this certificate attached. Now, it's at this point that the supplicant generates a random number using the server's public key and sends it to the server, which is sent in a client key exchange that only the server can decrypt. Now, this is sent in a client key exchange. Now, after this, the server and the supplicant generate a master session key. Now, phase 2 can now begin by the server sending an EAP request identity message to the client that's protected in the TLS tunnel. Now, the server uses authentication methods such as MSCHAP, MD5, or ETLS, and both the authentication server and the supplicant work out the EAP method. The final step in phase 2 is the success message. After this, the four-way handshake takes place. And that actually brings us to the end of Module 3. And here's what we've discussed in this module. We first talked about some of the terminology used for packet analysis. Then we had a section called What's in a Frame, where we dissected different frame types. We then finally talked about 802.11 security frames. And now it's time to test your knowledge based on what you've learned in this module.